Hi there guys, Grace here with another pre-calculus trigonometry question. And the question that we have is that we need to find the values of the trigonometric functions of theta from the information given. And so the two pieces of information we were given is that cosine theta is going to have a value of -2/3 and tangent of theta is less than 0. Now, what does that mean exactly? Well, they want us to find the other values not given, and what we were only given was cosine theta. And if we remember the trigonometric identities, we can see that we have 5 other identities that we're going to have to find in order to solve this equation. And so the first thing we need to unpack is how to find the position of theta. Now, I have a unit circle here for reference, but I want you to focus on this chart. There's a couple things that we need to make sure makes this statement true. And so the first thing I want us to look at is that tangent theta being less than 0 means that that is a negative value. And so if you look at this chart that I've made, tangent theta is a negative value between 120 to 180 degrees. Now, if we also see tangent theta exists as a negative value between 300 and 330 degrees. So that means that in order for theta to be true with this statement, we have a situation where theta could exist between quadrant 2 or quadrant 4. Now, because we were also given this information where cosine theta is a value of negative, don't worry about the 2/3 just yet because we just want to focus on that negative. We want to go ahead and reference this table again. And if you can see that cosine theta has a value negative between 120 to 240 degrees, we can then narrow exactly which quadrant is going to make this statement true for us, and which that's going to be quadrant 2, because cosine theta is negative between quadrant 2 and quadrant 3, and tangent of theta is less than 0 between quadrant 2 and quadrant 4. And so the shared quadrant between the two is quadrant 2. And so in order to solve this problem, let's go ahead and take a look at our Pythagorean theorem. And that's how we're going to start determining the other values that we need to find for this equation. And so the first thing I like to do is go ahead and make a graph, because we're going to label each part that we need in order to solve for this equation. And so I'm going to go make a triangle, a right triangle in quadrant 2, because that's where we're going to be determining our trigonometric functions. And that because we're given cosine theta being a value of -2/3, we can then go and refer back to our identity and see that our cosine theta is a value equal to adjacent over hypotenuse. And so that means that our theta value has an adjacent value with cosine theta of -2. Now, the reason why I'm giving this a negative value, there's 2 reasons. One being, if you can imagine this being a graph where we would have positive values for x on this side and negative values for x on that side, we can then see why this would become a negative value in relation if it fell in the quadrant 2 value. We also need to understand that any hypotenuse value must be a positive, because they do not exist as a negative value. And so if we see that we have the hypotenuse side, hypotenuse is going to be our value r, and our adjacent side value will be our value x in relation to this Pythagorean theorem of x squared plus y squared equals r squared. Now, we can start solving for our adjacent, or our opposite side, and that is going to be our y value. Now, what we're going to do is plug in for the formula x squared plus y squared equals r squared. And so we got -2 squared plus y squared equals 3 squared. And if we go ahead and solve for that, we got 4 plus y squared equals 9, and then y squared equals, got it, minus 4 here, minus 4 here. Y squared is going to give us a value of 5, and then we're going to go ahead and square root both sides to give us a plus and minus the square root of 5. Now, when we get to this point, we need to go back and refer to our unit circle that we have. And so that's why I like to create a chart, a graph, because it's really good to see visually exactly what value I need to consider. And so you can see that our y value, as in relation to the plus and minus here, when us determining which one to use, we can see that in quadrant 2, our y value should be a positive value. And so we now have determined that our y is going to be a positive square root of 5. Our x is going to be -2, and then our r is going to be 3. Now, these values are going to be really important because we're now going to start solving for our trigonometric functions. And so let's start with sine theta equals, so we have the opposite over hypotenuse. And so let me go ahead and put this back up here for reference for you guys. But you can see that when we're considering the opposite, we have a positive y value of square root of 5. And then the r value, which is our hypotenuse, is going to be 3. And so that is going to be our sine theta value. We then already have our cosine, so we don't need to worry about that. But now let's focus on our tangent theta value, which our tangent theta is going to be our opposite. So our value of, oops, sorry guys, square root of 5 over our adjacent, which that is a value of -2. And so we're going to be given then a value of negative square root of 5 over 2. So let's move on and find our cosecant theta. And that's going to be hypotenuse over opposite. And so that's 3 square root of 5. Our secant theta, which is hypotenuse over adjacent, is going to be 3 -2. And then our cotangent, which is our final function that we're searching for, is adjacent over hypotenuse. And that's going to give us a value of -2 over the square root of 5. And so we can see that all of our functions together, once we determine what position our theta in, and we determine what values our opposite, adjacent, and our hypotenuse are, as well as our trigonometric identities, we can then start breaking down how to solve for this equation, which the solution will be given is sine theta equals a square root of 5 over 3, tangent theta equals negative square root of 5 over 2, cosecant theta equals 3 over square root of 5, secant theta equals -3 over 2, and the cotangent theta equals -2 over square root of 5. Thank you so much.